So here we've been given the description of the transformation and we need to put it into function notation. So we're going to again separate our vertical and horizontal, and we're going to start with the vertical first. So it says here that we've been vertically compressed by 1/2 and then down by 8. So when we look at our f of x, we're going to end up with y equals, and on the outside, we're going to have our compression first, so 1/2, and then our translation last, so -8. So that's what my vertical transformation looks like. The horizontal transformation then is what we're going to do next. But the horizontal, we have to be careful because it happens exactly in the reverse of what it says. So going from our old x, we're going to do +3 first, +5. We're going to then expand everything by 3, and then we're going to horizontally flip, and that will get us to our new x. Okay, so this is what would happen to the coordinates. The notation, though, is going to be exactly backwards of this. So we're going to solve for the other x. So we can end up with the old x is going to be, we're going to divide by -3 first, and then we're going to subtract 5 last. Okay, so writing this then, this becomes our notation. Okay, this expression represents the notational form of this transformation. So this is what I put into my f of x. So it's going to be x over -3 minus 5. Notice that it's not in factored form because we did not do the expansion and flip first. We did our shift first, which is backwards of what the factored form would do. So we can leave it like that. We could also, alternatively, we could actually factor this, and we can factor the -1/3 out. So I end up with x, and then factoring that, we're going to end up with +15. And then this would be the factored form. So an equivalent, an alternative, would be putting it into the notation, into f of x, as x plus 15 over 3, and then we need a negative on that. So that would be an equivalent. This would be the equivalent factored form. I'm just going to maybe highlight that. So this represents the factored form of that function notation.